So here we have Bayes' theorem. Now it is an important concept and we will use naive Bayes algorithm that is based on this theorem in our modeling module. So let's see what Bayes' theorem is. Bayes' theorem is an extension to the law of conditional probability that we saw in a previous slide. It defines the probability of occurrence of an event related to any condition. It is given by the formula shown here. Now this is the general form of the formula, which means x can take multiple values, which means there could be multiple possible cases of x, and we want to know the conditional probability of any of the case given a certain condition. For example, there are 3 painters who have submitted their paintings in a competition, and we want to find the probability of one of these painters winning the competition. So here x can take value of any of the painter. Now from the general formula, we can also deduce the formula for special case for 2 events. And the formula for special case for 2 events is given here on the screen. Now let's understand this with the help of an example. Suppose you have planned to go to a picnic with your family, but you wanted to be sure if there will be rain or not. So first thing you checked is the forecast and found out that there is a 10% chance of rain. The forecast also tells us that the weather will be cloudy, and the chance for weather being cloudy is 40%. And it also says that 50% of the time the weather was cloudy when it had rained in the past. So now based on this information, you want to know the probability of rain on the day of your picnic given the weather is cloudy. So we can use Bayes' theorem in this case as shown here on the screen. Here rain is our x and cloudy weather is our y. The formula says probability of rain provided the weather is cloudy is equal to probability of cloudy weather when it has rained, that is 0.5 in our case, multiplied by probability of rain, which is 0.1 in our case, and divided by probability of y, that is probability of weather being cloudy, which is 0.4 in our case. We will put in these values and we'll get the probability of rain when the weather is cloudy as 0.125. So that is how we use Bayes' theorem. Now moving on to the next topic, that is random variable. So what is a random variable? By definition, random variable is a set of possible values from a random experiment. And random experiment is the one whose outcome is uncertain. For example, we roll a dice. The possible outcomes here are 1, 2, 3, 4, 5 and 6. Now the variable x can take any of these values. Hence x is a random variable. We use random variables because in an experiment there could be n possible outcomes, and mentioning all the outcomes every time we use the experiment is not a wise thing to do. So we use random variable to denote the possible outcomes. Now the probability of the possible outcomes of a random variable is given by probability function. There are 2 types of probability functions. CDF, which stands for cumulative distribution function, and PMF or PDF. Now in the case of CDF, whether a random variable is discrete or continuous, it is given as fx is equal to probability of capital X, that is a random variable, being less than equal to small x, which means any value of x. Now it could be a uniform or normal distribution, etc. We will learn these distributions in the upcoming slides. We will also see one example of CDF in a while, but before that let's understand what is PDF or PMF. So probability mass function is used when the random variable is discrete. So PMF can also be derived using CDF. When the random variable is exactly equal to small x, then CDF becomes PMF. So here we find the probability of a random variable capital X being exactly equal to small x. So PMF could be a graph, equation, table, Poisson or binomial distribution. Then in case our random variable is continuous, so we use PDF, which is probability density function. Now it tells us the probability of a random variable capital X being not equal to a particular value of small x. Here probability at a particular point is 0. Again, it could be a uniform distribution, normal distribution, etc. Now let's see one example of each of these distribution functions. So first we will see CDF. Say in a group of students, probability is equal to 0.7 is found using CDF at x is equal to 80%, which means there is a 70% chance that a randomly selected student will have a score less than 80%. Remember, it gives us the probability of being equal to or less than x. So that is how we use CDF. Now an example of PMF would be, let's say a company sells 2 homes per day and we need to find the probability if it will sell 3 homes tomorrow. So here we can use PMF because we want to find the probability of a random variable capital X being exactly equal to a certain value of small x. That in our case is 3 homes. So here we can use PMF. And lastly for PDF, we use it in several places. And we'll see this in our course throughout. It is used for any continuous variable that follows normal distribution, such as human IQ data, etc. So that was a quick brief about the probability concepts that we need to know right now.